Okay, welcome back. In this video, we will go over Chapter 5, the Skeletal System. Alright, the skeletal system is not just the actual bones of the skeleton. Of course, that is the biggest part. But in addition to the bones, you also have different forms of cartilage, you have different types of ligaments, different kinds of joints. So all that together is the skeletal system. And the skeleton is divided into two major divisions. The axial skeleton and the appendicular skeleton. For the axial skeleton, that is the skull, the rib cage, and the vertebral column. It's basically the backbone. Everything else, the arms and the legs, are the appendicular skeleton. That's why the arms and legs are called appendages, because they are part of the appendicular skeleton. So you need to be able to distinguish which one is which. So if I ask you on a test, the arm is in which of the following divisions? Arm would be in the appendicular. Alright, and here's a graphic with both of those here. This lighter color is the axial skeleton. Now the skull, sternum, rib cage, and the vertebral column. Everything in this, I guess, bluish, purplish color would be the appendicular skeleton. So the shoulders down to the hands, and the pelvis, all the way down to the feet. So everything associated with the arms, everything associated with the legs, appendicular, and everything else, skull, chest, and spine, would be the axial skeleton. Next we'll go over various functions of bone. Some of these are going to be, or should be obvious, and some you may not be familiar with. The first one's support. The legs and the pelvis and the vertebrae help support the body's weight. Protection, of course, to protect the organs inside the body, the heart, the brain, liver, and so on. Movement. Your muscles have to have somewhere to attach to, so your body can move, and muscles will attach to bone. And the last one we mentioned earlier, I believe in Chapter 1, a process called hematopoiesis. That is the formation of blood cells. So white blood cells, red blood cells, platelets, all of those are actually formed within the bone marrow of bone. So that's why any disease or disorder that focuses on bone marrow can be so dangerous. So that's the process is called hematopoiesis. Alright, next we'll go over the various types of bones. And something I did want to mention here briefly before we get into the types of bones. Sometimes people think that the skeleton is very static and doesn't really do a whole lot, but the exact opposite of that is true. Bones are consistently being stripped down for their minerals and being built back up again, and stripped back down and being built back up again. It's a very constant going process, a very dynamic process. So on average, a person will lose about 20% of their skeleton every year. Of course, that will vary on overall health and age and gender. So the skeleton that you have right now, as you listen to this, in about anywhere between 5 to 10 years, will be completely replaced. So it's a constantly moving process. And bones that you have are classified based on their shape. They're either going to be long, short, flat, or irregular. And I'll give you some examples of these. The first one, long. These are, like the name kind of implies, they're longer than they are wide. Examples include the femur, which is the bone in your thigh, and the humerus, which is the upper arm bone. These are going to be longer than they are wide. They are long if you were to look at them. Opposite of that would be short. They are cube-shaped and they're equal in length and width. So they're not long. They're basically like a big dice. There's one big cube. Examples of these include bones in the wrist and bones in the ankles. And there's a special type of short bone called round. These are also known as sesamoid bones. And they're called that because they resemble sesame seeds, like in a hamburger bun. And these are round bones that are found within tendons. And a good example of this would be the patella, which is the kneecap. That is technically a round bone or sesamoid bone, which is a subdivision of a short bone. The last two, the first one, flat. These are going to be very broad, very plate-like. Examples would be the scapula, which is the shoulder blade. Some bones on the side of the skull tend to be very flat and broad. And also the sternum, very flat and broad. And the last one, irregular. Again, like the name kind of indicates, these aren't long, they're not short, they're not flat. They just look strange. They just look weird. And there's no other way to describe them as if they're being irregular. And a good example of these type of bone are the vertebrae. All right. Here's a summary with all these. The humerus, long bone, that would be the upper arm. Now it's longer than it is wide. Same thing with the femur here. Long as opposed to short. Short, image uses the talus, which is the bone in the ankle. It's not long, it's not irregular, it's not flat, it's equally long as it is wide. So that'd be a short bone. Flat bone, example would be the sternum, right here. Very flat, very broad-like. Also, the parietal bone of the skull right here, very broad, very flat-like. And the vertebrae would be irregular. It's not short, it's not long, it's not flat, it's just weird looking. So it's called irregular. Alright, when we talk about bones for this chapter, we'll focus on the long bone, because we have so many of those, and they have a very specific function. So we'll focus on the components of the long bone. And here are the various portions. The first one, epiphysis. These are found on the ends of the long bone. So think of E for epiphysis, E for the end. And these are what actually will form a joint with other bones. And the formal name for that is called an articulation. The shaft of the long bone, the middle part of the long bone, is called a diaphysis. And there's a very tough, very dense covering that wraps around all long bones. It's called the periosteum. This is a very tough connective tissue that helps to protect the shaft of the long bone, the diaphysis. Here's an example of a femur, which would be the thigh bone. This would be the back part of the right femur. So this end here is an epiphysis. This end here is an epiphysis. This part would form the joint with the bones of the lower leg, the tibia and fibula, and this part would form the joint with your pelvis. So the ends are the epiphysis, and then the shaft of the long bone would be diaphysis. Alright, this part here that's pulled back so you can see inside is the periosteum. That's a very tough, very strong type of connective tissue that's there to protect the shaft or the diaphysis of long bones. There are two types of bone found in long bones, spongy and then compact. We'll focus on compact here first. The compact bone is tightly packed inside the shaft of the diaphysis. It has to be packed tightly to be able to support the weight of the body. So think of this as tile on a kitchen floor. There's almost no space in between each unit of these. And within this compact bone, you have a hollow chamber that's formed. And this is called the medullary cavity. This is where you find the bone marrow. And this cavity is lined with a type of membrane on the inside called the endosteum. So remember, endo for inside. So the inner lining of this medullary cavity is the endosteum. So if you were to take a long bone, cut it in cross section, this is what you would see. This yellow stuff would be the yellow bone marrow. This inner space here, this chamber here, that runs the length of the long bone, would be the medullary cavity, and the lining is in here would be the endosteum. And some of these terms we won't talk about, so not everything on these images you'll need to focus on. Alright, these bone cells were formerly called osteocytes. Osteo is reference to bone, and cyte means cell, so literally bone cells. These are found in very predictable, very easy to find units, and they're laid in concentric circles around a central canal. And these cylinder-shaped units are called osteons. Remember, osteo for bone. Or also, you'll see them referenced as Haversian systems. Either term is fine, but we'll use osteons for this class. And these osteocytes, the bone cells, will actually rest in small pits, small cells, or spaces within these concentric circles. And those pits are called lacuna. And lacuna is a Latin word that means lake. And I'll show you how this looks. This cylinder unit is pulled out. That's one unit. That's one unit. That would be an osteon. And going back to this picture here, looks like a bullseye symbol or like a target symbol. One of those is an osteon, and they all are based on concentric circles of calcium around the central canal. All right, and the bone cells, the osteocytes, rest in these little dark pits called the lacuna. And they're easy to spot on an image like this. You should remember an image like this when we talked about bone tissue from chapter 3. Now, this space from here to here is one osteon, or one Haversian system. And these formed by these concentric circles of calcium, and these little dark markings here, there. Those dark spots, those dark pits, are the lacuna. Inside of these is where you'll find the osteocytes, the bone cells. So that's one osteon. That's probably about 70% of one here. The rest of it gets cut off by the slide. Okay. So go back to this. This is what these are. This illustration, and that's real, how it actually looks. Alright, that's all for compact bone. The compact bone is only found in the shaft of the long bone, the diaphysis. On the ends, you have another kind of bone. It's called spongy bone. And these are also called trabecular bone. These have bony plates. These bony plates are called trabeculae. And these form several these spikes form space-filled areas. And it looks like a kitchen sponge. That's why it's called spongy bone. It looks very different from the compact bone, which is very tightly compacted together, like the tiles on the kitchen floor. There's literally no space between those osteons. But for spongy bone, there's a good amount of space between those bony plates, the trabeculae. So if we were to zoom in on a real bone here, it looks like a kitchen sponge, very airy, and these spaces you can easily see. That is nothing like this. Very tightly compact. That's why this is called spongy bone. And these little bony plates are the trabeculae. Alright, next we'll talk about bone growth. As a fetus will develop, the longer bones start off as hyaline cartilage, which is a form of cartilage. Bone tissue will start to replace that cartilage as that fetus will develop further and further on. And it will start in the middle, dead center of the shaft of that long bone, the diaphysis, and it will continue outward until the bone is fully ossified. There's a band of cartilage that's formed that separates the shaft of the long bone from the end, or the epiphysis of that long bone, and this space is called the epiphyseal plate. This is where growth occurs in long bone. This is how limbs get longer. This is how you get taller up to a certain age. And this is how that would work. See an embryo here and the fetus here. This light blue coloring would be the hyaline cartilage. And here we're showing the beginnings of bone growth, where the bone will actually replace all that cartilage. So it starts off in the middle of the long bone. This part will grow upward, and this part will grow downward, as indicated here. And this will continue on, and this is how this bone will get longer, and how the fetus will get larger in size, and this is how you get taller, as you get older. And then when you're, say, a young child, not only does it grow up, but also start to grow outward, to get thicker and to get stronger. And here's the epiphyseal plate here. It's the boundary between the ends of the long bone, the epiphysis, and the shaft, diaphysis. This is where the growth actually occurs. From here you get cells that are growing and moving it down. Here, moving it down. That's how the bone gets longer. Okay. Here's another way to look at it. Looks like a femur is laid on the side. The shaft, or the aphysis here. The epiphyseal plate here, separating the ends from the shaft. Also right here. So the end, or the epiphysis, from the shaft. Okay. This is how an X-ray would look of a younger child's bone. This is a good way to tell someone's approximate age, and we'll talk about why that is here next. But in someone who's under probably 18 or so, the epiphyseal disc or plate is very, very pronounced. This would be this child's femur. This would be the lower leg, the tibia, the shin bone, and here in the back the fibula. But this is where the growth would actually occur for that bone here and for that bone here. Now, as we get older, these epiphyseal plates will get smaller and smaller and smaller to the point where it's fully replaced by bone. It's fully ossified. At that point, you cannot grow any taller no matter what you do. There's nothing you can take to make it continue on. There's no pill, no shot. Once you get to a certain age, if for females, it's probably about 19 or so, 19 to 20. For males, it's about 21 to 22. Of course, that will vary depending on each person. But once that epiphyseal plate is fully ossified, you can't grow any taller. And there are two terms for this. Epiphyseal plate is what we just showed on the X-ray, where you actually have the growth of growing a younger bone. That's what you're able to see very clearly on X-ray. That's epiphyseal plate. When that band of cartilage gets replaced by bone, you don't see that wide space. You see a very faint line. That's called the epiphyseal line. That's what's left over in an adult bone. So this is very clearly indicated here. Epiphyseal plate. So if you were to take an X-ray of my son, he would look similar to this. Very noticeable line of growth, because my son's only 6 years old. If you were to take an X-ray of my leg in this exact same position, you see a very faint line, because I have stopped growing because I'm well beyond my 20s. So don't confuse the epiphyseal plate with the epiphyseal line. So plate are in the younger growing bone. Line is when everything is already turned into bone and you can't get any taller. Alright, next we'll move on to different types of joints. Joints have multiple forms. They vary greatly in their function and in their structure. And joints can be classified by two main ways, either by how much the bones are able to move, or by what tissue will bind those bones at that joint, at that junction. And we'll focus on how they're classified by tissue types. And there are three types in this category. You have fibrous joints, cartilaginous joints, and synovial joints. The first one, fibrous joints. These are where you have bones held very closely together, very tightly together by dense connective tissue. And these bones are going to be in very, very close contact. And a good example of this are the sutures in the skull that are found in the flat bones of the skull. This is the only place where you'll find sutures as a joint, will be in the flat bones of the skull. So the skull isn't one big piece, it's really one big massive jigsaw puzzle. So if you were to look at a skull, this is actually how it would look on the top. And if you were to break these pieces apart or take it apart like a puzzle, it looks very jagged, very serrated, just like this. And it's not because it's broken, that's actually how it looks. It's how that segment of the skull looks. And these pieces fit together like a puzzle. So this is what's called a suture. So this is a fibrous joint. So these bones are held very closely together, and it's also how you get the soft spot in a young child, a newborn child, because these bones haven't fully grown over yet. That's why you get that dip, that soft spot, because all you feel is that's connective tissue, and bone hasn't fully grown over it yet. Next one, cartilaginous joints. These are held together by a different type of cartilage. It'd either be hyaline cartilage or fibrocartilage. An example of a cartilaginous joint that uses hyaline cartilage is the epiphyseal plate. And technically, this is a temporary joint, because once you get to your 20s, this epiphyseal plate will be gone, and so that joint is no longer there anymore. So that's an example of a hyaline bound joint. Examples of a fibrocartilage bound joint are the bones in the pelvis and also the vertebrae of the spine. In between each vertebrae of the spine is a disc of cartilage to help act as a shock absorber. So when someone says they have a slipped disc in their back, that's usually what they're referencing. that cartilage is either worn out or has actually moved, and that's why it can be so painful. Alright, here's some examples. The epiphyseal plate here in this long bone for the hyaline cartilage joint. The space here in between the vertebrae, fibrocartilage. Also in between the bones of the pelvis, there's a band of cartilage found in between the two wings of the pelvis here, which allows it to separate, which is important for women during childbirth. Our next one is the most complex type of joint and also the most common. If you were to think of a generic type of joint in your body, most likely you'll be thinking of a synovial joint. One key thing that's found here is synovial fluid. This is produced by a very particular membrane within these joints. It's produced to reduce friction, which is what you need in joints like your shoulder or your knees or so on. Because these joints are used so often, you need to have some protection so you don't have bone rubbing on bone. And there are 6 different types of synovial joints. Here's an example of how one would look. This would be the shoulder and the shoulder blade, so the upper arm. And this space right here is where you would find the synovial fluid to help lubricate the arm being able to move freely. Because if not, then you'll have this bone rubbing against the shoulder blade, which would be very, very uncomfortable. This is true for all synovial joints. Now, some of these are going to be fairly well known. Some of these you may not be familiar with. The first one, hinge. This is where you have movement in only one direction, only one plane. An example of this is the elbow. The elbow should normally just go in one direction. You can either open or close. It can flex or extend. Think of this as a hinge on a door frame. Doors can only open in one direction, barring some type of injury. So we're talking about a normal situation here. Next one, pivot, where you have a cylinder-shaped surface on where a bone can rotate. An example of this is the radius and ulna, the bones of the forearm. They're able to rotate over one another, and also on the bottom of the skull. This is how you're able to rotate your head left and right. You're able to rotate it due to a pivot joint between the top vertebrae and the base of the skull. And probably the most well-known of the types of joints we'll go over, the ball and socket. You have an egg-shaped head of one bone that fits into a cup-shaped space of another bone. An example of these include the hip and the shoulder. These types of joints give you the most amount of movements for a type of joint. This is how they would look. Say a hinge joint, only able to flex and extend, open and close. Pivot joint. We mentioned the bones of the forearm, or the ulna and radius. Same thing with the bones of the lower leg. They're able to rotate over each other also. And ball and socket. You have a ball fitting into a socket. It's like the shoulder joint between the humerus and the scapula. Same thing with the hip. Alright, next 3. Condylar or ellipsoidal. Sometimes you'll see it called ellipsoidal. You have an egg-shaped condyle, which is a large rounded mass of one bone fitting into a cavity of another. An example of these include the bones within the hands. And they're able to go twist and kind of glide by each other. Next one, plane, or also called gliding. These allow for twisting and back and forth motions. You'll see these in the joints of the ankle and in the joints of the wrist. And the last one here is saddle. The bones have both a convex and a concave region to them. And a good example of this is the thumb. The thumb can not only flex and extend, but also can spin around. So this is the only place you'll find the saddle joint is in the thumb. Alright, so a condyloid or condylar or ellipsoidal, the bones of the hand here. Gliding or plane, bones of the feet or the ankles and of the hand, they're able to go this way and this way. And saddle joint of the thumb, able to go in multiple directions. Alright, that brings us to the end of the chapter on skeletal system. Again, strongly encourage you to keep up this material on a daily basis. If you have questions, please feel free to contact me.